Databases, in short, if I have to put it in a quick, in short, what we say is all databases, let me put it this way, all data warehouses are databases. All databases are not data warehouses. Make sense? Very important. I think it's just a very fundamental concept. I'll come to some of the more important differences in a while, but it's probably the most a very broad difference between the two, right? How do you what is the difference? So essentially, when we talk about a data warehouse, whenever we say a data warehouse is nothing but a database, right? Because a data warehouse is not something that you create outside of SQL Server. It is just like a database. That's the same reason why if you see AdventureWorks CW 2014, it's the same demo. It's the same default Microsoft supplied data warehouse that we have been working with, and that's basically what you have available in the databases section. You don't have a separate data warehouse section, right? So whether you take an OLTP database and any kind of databases, or you take a data warehouse, they are all databases, right? So, but then all databases are not data warehouses. So, and I'll again talk somewhat in more detail about specifically what is the difference. But then just remember this thing that when you have a data warehouse has a distinctly different schema when you compare to a normal database, right? When we talk about database, we typically talk about an OLTP, right? Online transactional processing, typical normalized tables, right? That's what we typically associate with a database. The moment you talk about data warehouse, the whole terminology changes, and you have a completely different way of modeling a data warehouse. So whereas databases we typically model using the ER modeling, which we call entity relationship modeling, data warehouses we typically do modeling using dimensional modeling. We identify facts, you identify dimensions, and all the things that we've been doing in SSIS. So that is all that you cover in data warehouses. So so the entire schema is very, very different in data warehouse, but still it is still a kind of a database. So just keep that in mind as the very first point. Okay, so all databases warehouses are databases, but all databases are not data warehouses. And the other thing that I initially mentioned, that when we typically talk about a database is always I mean it's always linked to an OLTP system, right? So you have an OLTP system. An OLTP system, you can think of it as it's typically again the full form stands for online transactional processing, right? And I'm sure all of your database folks here, all of you understand what is an OLTP. And you understand it, an OLTP system is what is used to run your business, right? You can think of a typical ticket reservation system or a flight reservation system. You can think of an order management system, where these are things that are used to run your business. Okay, customer places an order. A new record is created in the orders table. A new customer gets added. A customer calls into a call center. The call center agent fetches the details of the customer. So it's the entire system through which your business runs. That's basically OLTP. That's why we call it online transactional processing, right? Why do we call it transactional processing? Because every single order that you place, every single time you visit that store and purchase something, you are essentially contributing to a transaction. Okay, and because of that transaction, new rows are being added, updated, or deleted in the corresponding tables. Right? It could be an order table where a new order is added. It could be a customer table where a new customer detail is updated. It could be the invoice table where you're adding a new invoice. So that's the reason why we call it transactional processing. Your business runs on that. Okay, so databases, when we typically associate, they're always OLTP systems, right? And the other thing that I already talked about is, the typical way in which you model it, and I hope you all got the difference here, is we call it online transactional processing. This is what we call online transactional processing. Okay, that's an OLTP system. And the moment you come to ER modeling, that's the second property I would like to list out for a database when we typically associate with a database. And ER modeling basically stands for entity relationship modeling. Okay, that's what we call entity relationship. The E stands for entity, the R stands for relationship, and entities are basically, you can think of it in the form of tables. So what are entities? Entities are the different tables, and what are relationships? relationships are the relationships between those tables, you know. So when you relate the table A to table B, you always have a primary key, you have a foreign key, and you relate those tables. So that is how you typically do the modeling. So the next time you have to design a very complex ticket reservation system, and again this is part of database design, the very first step of the project, where you're going to do this exercise. You're going to first identify, there's a lot of methodologies around it, you know. People do a lot of different ways in which they arrive at that model, but then broadly it is about identifying the entities. It is about identifying what are my entities and how do those entities interact with each other. Okay, so the part of identifying those entities become your tables. So the entities become your tables, and how the entities interact with each other essentially become your relationship. So if you know that the customers table and the invoice table are going to interact with each other, then there is definitely a relationship between the customer and invoice. So next time when the customer places an order, the invoice is linked to the customer. So that is how you do an ER modeling. Okay, again, it's not in the scope to actually get into the details of exactly what it is. I mean, what ER modeling is. I'm not going to get into designing the ER model. I'm not going to show you the modeling part, but just wanted to give you an overview of what an ER modeling is. Okay, that's again a very, very important part of a database design. And another very, very important concept, and this is probably one of the most important concepts, is that databases are typically normalized. Okay, they're typically normalized. So unlike data warehouses, I'll come to that later, but then databases are always normalized. So something that most of you would have learned in your college levels, right? First level, second normalization, third normalization. Okay, 1NF, 2NF, 3NF, you would have all learned this, right? So this is where you are trying to break a large table into multiple smaller tables. I'm giving you a very simple analogy. Okay, there are multiple other things associated with normalization. You can look up what is the first level, what is the second level, what is the third level. So broadly, the first level is about removing all the duplicates, you know, making sure that you have atomic entities. Okay, the second level is more about ensuring that the primary key, you know, if you have any kind of all the non-key columns are essentially linked to your key columns. And finally, the third level is about ensuring that there is no transitory relationship. Right, so ideally, a simple analogy could be that if you have sales, and if you're calculating profit is basically it's kind of like a calculated column. So profit is always calculated on your kind of one way to put it would be, let's say profit is calculated on your sales. So if you have the sales column, if the sales is 20,000 and you're saying profit is always 10% of your sales, then essentially that profit column is kind of dependent on your sales column, but profit column is not really dependent on the primary key of that particular table. So essentially, the whole point of 3NF is to make sure that you remove these kind of transitory relationships. Where in short, analogy could be that 3NF tells you that try to remove all calculated columns from your tables. But then, without getting too much into the details of normalization, you're trying to break your table into smaller pieces, right? You have one big chunk. You've identified an entity. As part of ER modeling, you've identified an entity, but then you somehow feel that as part of normalization, you're going to make sure that you break down that one big table, that one big entity that you identified, into multiple smaller chunks, right? So that's the whole point of normalization. I'll come to the benefits of it in a while, but then one of the major benefits of normalization, and again, the normalization, as I said, is breaking into multiple. One of the major benefits is that you have faster inserts, updates, and deletes. Okay, you have faster inserts, you have faster updates, and faster deletes. In other words, I can call it efficient inserts, updates, deletes, right? And that's how it should be, right? That's how it should be in a typical OLTP setup, right? Because that's what your business runs on. The next time when a customer places an order, essentially what you're doing is you're updating the orders table. You're trying to insert a record into the orders table. You don't want that customer to wait forever for that order to be updated, right? Because all these things happen very, very fast. You know, if your OLTP system is what your business runs on, you have to make sure that your inserts are happening super fast. Next time when some details are updated, let's say the customer places an order, you have an inventory table. So based on how much was ordered, the inventory table has to be updated, because if the inventory table is not updated properly and super fast, almost in real time, the next customer's order may not happen, because all these orders happen very, very fast. So you can understand the scenario, right? You can think of a typical retail store where All these things happen real time. Multiple customers are trying to place an order at the same time, right? So it has to be super fast. So the whole point of having normalization is to ensure that your inserts, updates, and deletes are indeed very, very fast. Okay, so you try to normalize these tables to as granular a level as possible. Okay, when I say granular in BI terms, granularity means detail. So the more granular it is, the more detailed it is. Okay, so I'll take a quick scenario where I'll talk a little bit about why I'm saying that inserts, updates, and deletes are fast. I'm going to quickly open up a Word document. It's kind of an Excel sheet I'll open up. So I've opened up my Excel sheet. So what I'm going to have here is a sales table. I'll call it sales, and I'll also have this is my sales table, and probably I'll call this my country table. Right, so just going to have some little bit of spacing here. It's my sales table. So sales table, I'll have my ID, and I'll have my sales. And maybe just have another country column. For the time being, I'll talk a little bit about the disadvantages. Then I'm going to show you why I need a separate country table. And again, briefly, what I'm saying is I'm doing a very basic level of normalization here itself. So I'm going to talk a little bit about that in a while. So let's say this is sales ID. Okay, and essentially you can call this invoice ID or whatever. Probably again, this is not the best of normalization practice. Okay, and again, I'm sure you can understand that the first question you'll be asking is, hey, if you have an invoice ID, you need a separate invoice table. I absolutely agree with you, but then just hold up on that. This is just an example I'm showing you. Idea here is to show you one level of normalization. Okay, I absolutely agree. Invoice should be a separate table. Let's just assume that invoice ID and sales are part of the same table. Okay, right. So this is one. Let's say this is 100, and let's say the country here is India. Let's say this is 2. This is 200. Country here is again India. This is 3. This is 300. Country here is again India. This is 4. This is 500. Country here is USA. It's 5. 600. Country here is USA. 6. 700. Country here is UK. Okay. All right. So what I have here is I have a simple sales table where you're maintaining details like this. Okay, and let's say there's a database that you're maintaining. Okay, now the problem is that next time when let's imagine a scenario where for some reason the country when I say India, what's happening here is that for some reason, let's say you need to make sure that India, for some reason you're calling it IND. Okay, I'm just giving an example. So what you have to do is you're looking at every record of that particular table. Every record of that particular table, I need to go to every single row. I need to update India to IND, right? So what you need to do is you need to update this to IND, you need to update this to IND, and you need to update this to IND, right? I'm just showing an example of update at the time at this moment, right? So if you have multiple instances of India, you have to go through and just imagine this is not it's not just 6-7 rows in a typical OLTP system. You're literally talking about millions or even billions of rows. That's the level of detail that can come in the sales table. I mean, sales is invoice data. You can understand that if you think of a typical store like Walmart, I mean, you literally have billions of rows, right? So you can't just go and update, find each instance of that particular country and update that country detail when some changes happen. And I'm just talking about country. Even you can just imagine about customer also. Maybe if you have a customer name, for some reason the customer's name got changed. So you have to go to each row, find out that customer and update that name. So one problem is you have duplication. Because of duplication, what is happening is that you're taking extra space. So the same IND that you could have stored this in a different way, but you're storing this, you're duplicating the values. And when an update happens, you have to basically go and update in every single row where India happened, right? So next time when USA, for some reason you decide that okay, USA, I'm going to rename it as US business requirement. You're going to go to every instance where there's USA and you have to update this back to US. Okay, and you can understand the problem with this. Okay. There's a major problem with this particular approach. Okay. Now coming back to the solution is very simple, and just think of a solution where instead of maintaining country like this, if you're maintaining country as a separate table, and all that I'm doing here is I'm having country ID and I'm having country name, and what I'll have here is country, and probably call it country ID just to differentiate it properly. Hope you can understand this is indeed country ID. right? So this is country ID, this is country name. Country ID is 1, country name is, I'll call it India. Country ID is 2, it is USA. Country ID is 3 and it is called UK. Okay, simple. And what I will do here is instead of having the names, I'm going to simply have them have the numbers, the corresponding IDs linked to it, right? So US becomes my 2 and UK becomes my 3. All right, so you can see the immediate benefit. So what I've essentially done is a very miniature version of normalization. Okay, so this was basically it was in 1NF. Again, I will not get into too much about the different levels of normalization, but then just for the folks, I just wanted to tell you that this was already in 1NF, right? All I did was I ensured that I enforced 2NF here. So now it is in 2NF. Okay, so it is in the second level of normalization. Okay, so 2NF is followed here, right? Make sense? And what is 2NF? 2NF basically means that every non-key column is dependent on the key column. So the key column here is invoice ID. So this is my primary key, right? This is my primary key. Invoice ID is my primary key here. Country ID is my primary key here. So every non-key column depends on your key column. Sales depends on the invoice ID. Country depends on the invoice ID, right? And if you see here, the country table also, the non-key column is name, and the name basically depends on your country ID. That's the key column. Okay, we don't have an instance of 3NF here, but I just had one of the questions that came in a while back, and let's assume I have a question, and I'll just come to the 3NF in a while. But just to take a cue from what we were discussing before, the inherent challenges of the previous approach, where next time an update happened, let's say the name of India changed to IND, you had to go to every row and you have to update IND. The moment this happens, one of the immediate benefits is next time when India changes to IND, all you have to do is you just have to update one row. That's it. You don't have to come to the sales table at all. And when you're talking about sales and country, you can immediately imagine that sales it has rows in billions, whereas country will have a number of records in only hundreds. Okay, if you look at the countries of the world, there are hardly 200 countries in the world, right? Yeah, I mean 200, roughly 200, 250 countries in the world, right? So you will have a total of 250 countries, and all you have to do is, if the name of the country changes, if you're using the all of a sudden as part of a business need, if you decide that hey, we need to use abbreviations from now onwards, all you can do is go to the country table and update the name instead of going to each row and updating across a billion records. Okay, you can immediately see how fast that update will happen. It's an excellent example of normalization, right? And the way we did it is your foreign key. This is what we call the foreign key, and this is what we call the primary key, right? Primary key is something that uniquely identifies each row of the table. So if you have country ID 1 is something that uniquely identifies each row. Why is it uniquely identified? Because country ID 1 stands for 1. Okay, primary keys can never be duplicated, and the foreign key is something that links back to that primary key. Okay, this is how you link the table. These two are your entities, and this is your relationship. That's your ER model that you formed. Okay, make sense? Make sense? What is the benefit of normalization? Okay. However, one major drawback of normalization, which I wanted to highlight on the same queue, I'll come to 3NF in a while. One major drawback of normalization is slower selects. Selects are very, very slow. I put it as slower selects. Okay. So what do I mean by this? And when I say selects, I mean to say select statements. Okay. Essentially, when you have to analyze data, when you have to query, and you have to draw up a result set. Let's say you're asking a question. Okay, hey, how was what are the total sales across for USA? What are the total sales for USA? If my question is like this, what was the total? If I'm asking a question like this, what was the total sales for USA? How do you think this question can be answered? How do you think this question can be answered from these two tables? Can I write a simple, okay, let me give you one scenario as this. This is one scenario where you have the sales and country broken up. And the other scenario is having one big table, and if we have that table here, the other scenario is having it like this. Let me just put it up here so that it's visible. Let me have the other scenario like this. Okay, and let me just put this up. That's my query. Okay, let me place it here. Let me place it here. Okay. So this is my sales table. Just draw some nice color coding. Call this my sales table. Call this my country table. That's my country table. And this is what I'll call my sales table. And this I will say this is not normalized. Okay, this is not normalized. And when I say not normalized, essentially the word that we use here is denormalized. I'm going to again talk about this when I talk about data warehouses, but for the time being, just remember essentially when something is not normalized, it is denormalized. Okay. All right. So go ahead and call this India. That's USA. That's UK. Okay. So I don't have the country IDs anymore. So just a small quick thing. I should ideally call this country ID. Okay. Makes sense? Makes sense. What are the changes we have done? Quickly add some color coding here. Go ahead and add some color coding. So what you can see here is I have so the first case I have two tables, one is sales and one is country, and the second case I have one single big denormalized table where I maintain the country names in the same table. Okay. Question is, what was the total sales for USA? If you're writing a query here, it's a very simple. It's a very simple select query, isn't it? It's a very simple select query. All you have to do is just select star. I mean, you're just selecting the sum of sales where country is equal to USA, isn't it? That's all you're doing. Yep. All you're doing is you're selecting the sum of sales. You're selecting the sum of sales. Yep. You're simply selecting the sum of sales from this particular table where your country is equal to USA, right? If you're thinking, why can't we use group by, why can't we use having? Well, essentially it will give you the same result because again, how a select query works is kind of, if you look at the exact order of execution of a select query, how it works is that first it'll execute the from. That's how the select query works. Okay, it's not the matter that this is how we write it, but then how the select query works is first it'll execute the from. It'll take the whole table. I'm going to just call it sales. You might get confused what this. So essentially the table name is sales. Yeah. Take the table name and apply the where clause. The where clause is what's applied next. That's the next step, right? So it's going to take the whole table. It's going to first apply that where clause. Now it's going to have where country equal to USA. Now the result set is just 2 rows. It just has 2 rows. And when you say sum of sales, without giving any group by any other clauses, it by default takes the entire result set. Okay, so that's how the select query works. So the other step, you could have done it this way also. You could have done it absolutely. You could have done it this way also. You could have done sum of sales from sales, and this is slightly complex, but then I mean, you could have done a group by. You could have done a group by based on country, and then you would have to add a having clause. And when you say having country is equal to USA, it means the same thing, but essentially it's not required. I mean, it's just adding a few more layers to the query. And again, it'll execute the same way, where first you're taking the table, then you're grouping by country. So if you're grouping by country, your result set is going to be basically okay, IND 600, USA 1100, UK 700. That's your intermediate result set. And finally, after group by, your country equal to USA works. That's the having clause that's applied after that. Okay, so always remember that where is applied first. Where is something that is applied right after from. Okay, you take the from, take whatever table you have, and right after that you apply the where. Okay, So these two will give you the same result, but essentially that's not what I wanted to highlight. But what I really want to highlight is this is a simple query you can write for from this table to get this data, right? What is the total sales for USA? The same thing if you write for this table, these two tables, what you have to do is you have to write a slightly more complex query because you have to join the two tables, right? You'll have to do something like sum of sales from sales, inner join, country, inner join, country, give an on clause. Essentially what you're going to say, sales dot, you're saying sales dot country ID is equal to country dot country ID. That's inner join. You've done inner join, and what you want to do is you just want to make sure that you filter it based on that particular country. Okay, so then you can say where country, where sales, or you can basically do where country dot name is equal to USA. Okay, make sense? That's the query that you will need to write for this. Now, what is the challenge here? The challenge is that essentially you're writing a much more complex query. And is the query really complex? Answer is no. But the most important thing I want to highlight here is that you are joining two tables, and joins are expensive operations. Okay, joins are pretty expensive operations. I hope this query is clear. Essentially, again, it's doing the same thing, just as we did here. So the same thing you can also implement using this. So I just have to quickly replicate this thing again. I'm sorry, I just cut it. So I'm going to go and copy it, and you can do the same thing here also. You're joining the two tables on the IDs. Instead of using the where, now you're going back and saying you want to group by. Now you want to group by based on country name. You want to group by based on country name, and you want to add a having clause where having country dot name table is equal to USA. All right, makes sense. So it's the same thing. Essentially, this query is very similar to this query. This query is very similar to this query, but the only difference is that in the first case you have to join the two tables because you can query only based on the names, right? So you're getting the sales from here, but you're getting the names from here. So to make sure that you're able to query properly, you have to join the two tables, and joins are expensive. Okay, which is one of the major disadvantages of normalization, and which is why I put it this way: that slower select statements. Right? Why are the select statements slower? Because, and I put this in brackets, more joins involved. Okay, so there are more joins involved. The joins could be inner join, the joins could be outer join, but then the idea is that the moment you break it into multiple smaller tables, and this again I'm talking about a normalization from an OLTP system point of view, you're trying to break one single big table into multiple smaller chunks. You basically, next time when you want to fetch some data, when you have to write a select statement, you have to do multiple levels of joins. Okay, and when you do multiple levels of joins, it takes a lot of time. So slower select statements, more joins involved, and they take a lot of time. Okay, so I put it as joins are expensive, joins take time. Okay, makes sense. The reason why I say that the select statements are slower, and essentially that's one of the major drawbacks of a database. So although you have very fast insert, updates, and deletes, which is because this is what your business runs on, right? This is what we talked about. Your business runs on this. Obviously, you know, for day-to-day operations, this is something you need. It's a requirement. But this is not a day-to-day operation. If you talk about an OLTP database, this is not a day-to-day operation. You don't need to query data, right? When I talk about querying data, the moment I ask a question like this, what was the total sales of USA? The moment I ask a question like this, please note it is an analytical question. It is not something based on which your business runs on. Okay, so we need to draw that line very, very clearly to understand, you know, what is this question all about? This question is something a manager will be asking, right? A sales manager, an area manager will be more interested in. You know, someone who basically runs day-to-day transactional stuff. They will not want to know what was the total sales of USA for last year, what are the total sales over the past 5 years, you know, how much of sales was contributed across the different regions, east, west, north, south, central. no day-to-day operational stuff are not dependent on that, right? These are questions which will be more relevant for folks at a much more management level, right? And which is what databases are not built for. OLTP systems are not built for that. And the other thing is that they store only current data. So current data, I'll put it like only current data is stored. No historical records are maintained. Another very, very important reason why we cannot use databases, OLTP databases, for running select queries or for running, when I say select queries, I basically mean analytical queries. So we typically don't use databases for running analytical queries. Okay, so because one reason is you don't have historical records. So even if you want to know, how did I perform over the past 5-7 years in my sales across the different regions, across different population categories, across different genres of products, you can't get that information because frankly you don't maintain historical records. So hardly 1 month, 2 months data you will maintain in a transactional system. It depends from in a case-by-case basis. People do archiving. There are SSIS packages that you set up on a periodic basis, which loads data on a monthly basis or on a quarterly basis from an OLTP database onto a data warehouse. Okay. So in an OLTP database, you hardly have a quarter's worth of data, or at the max a year's worth of data. That's what you basically have, and that's one of the other reasons why you cannot run select queries, analytical queries. Okay, and I'll put it this way. I'll again put this as a point: analytical queries cannot, and it's not only about cannot, you should not be executed. Okay, you should not execute, and one of the other reasons why see, one thing is that you cannot. When I say cannot, I mean to say that the performance will be very, very slow. It will take a lot of time because you have multiple tables. There'll be a lot of joins. You cannot execute it because you don't have historical records, but you should not execute it because the moment you run a select statement and the joins are going to take time, you are essentially you're bringing your production system to a halt. Okay, so essentially, if you think of running a select query in Walmart's database, where it's trying to calculate their very complex SQL query involving 10-15 levels of joins. So the next time a customer wants to actually order something, and when you're trying to actually do a transactional business transaction, that system is basically not available. That production system goes to a halt. So you should not run analytical select queries against a typical OLTP database. Okay, so that's one of the very, very important points that I wanted to highlight. All right.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.